So we'll be happy to answer any questions you might have. Yes? So how wide is the crack that I showed on the nucleus? I think it's a couple of meters is what they've measured. It's not a big gaping chasm, but it's certainly several meters wide. I think the resolution of those images is something like 0.5 meter per pixel, and so we could go in and measure it, but it's certainly 5 or 6 pixels across at least. But it's just an interesting observation, and now that we've seen it, they're going to have, they will track that area and see if there's material coming out of it, if that's where a vent is that the gas and dust is being ejected from, if it starts widening with time. So we'll see. So the question is, if Mars had life, how long ago could that have been? And the answer is we really don't know. That's what we're looking for. But the evidence seems to be pointing to early Mars was warmer and wetter than it is right now. At the current conditions, the atmosphere is thin enough that you cannot have liquid water existing on the surface. Yet we see dry rivers in many spots, dry river beds that have been carved by, you would think, running water. We've got lots of evidence at the Curiosity site that was an alluvial fan they drove across and flowed into that crater. Both Spirit and Opportunity have evidence that the rocks in those areas were in contact with groundwater that percolated up through the rocks, possibly small lakes. So we know that the conditions were very different. What we don't know is, was that 3.5 billion years ago, 2 billion years ago, 100 million years ago? And so that's one of the things that they're hoping to do with this mission as they start going up the slope of that mountain, is look at, try to unravel what the conditions were like when these various layers of rocks were laid down. And we could only guess what that story is. Was it really wet to start with, and then was it episodic, or was it a sort of a continuously drying type of environment? So I'll keep you posted. 3.5 billion years. Well, when we talk about life on Mars, I think most people would assume that we're talking bacteria, not more evolved organisms. And that maybe is just a prejudice, but we know on the Earth we have a very rich fossil record. And the first life forms that we have record of happened, it was like longer than 3.5 billion years ago.
Yeah, I think 3.8 billion years
Something
is
like
the
that.
oldest life.
Blue-green algae. And it sat there cooking away as single-celled organisms until about 600 million years ago. And that's when we have evidence for multi-celled organisms. So that was 3 billion years that the conditions were conducive for life before it ever got complex. And of course, that's a sample of one.
Yeah.
That we only have this location, but that's what the information we have to work from. So there's lots of thinking that Mars dried out quite a bit earlier than that, or quite a bit longer ago than 600 million years. And so we'll see.
Is it assumed that the age of Mars is comparable to the age of Earth, like 13.5 billion years?
So is Mars as old as the Earth? And the assumption is yes, the solar system formed more or less at the same time. And that would be about 4.5, 4.6 billion years ago is the age of the Earth and the Moon and all of that.
The age
So
of Mars would be comparable to the age of Earth.
yes.
The age of 13.5 billion or more, plus or minus.
Well, the 13.5 billion
That's
years
the age of
is
the universe.
the age of the universe. So the solar system wasn't formed until 4.5 billion years ago.
Right.
Okay.
You're right, that's what I meant.
Yeah.
The age of the, 4 billion. And so, given that, can we assume that processes that happen on Earth would have happened at the same time on Mars? As far as cooling, as far as,
Well, certainly. I mean, we think it's gone through a similar progression where it's cooled down, the interior has cooled, but the size of the planet and its location in the solar system changes things to a large extent, especially the size. And that's what the MAVEN mission that's orbiting Mars right now, it's studying how the atmosphere is currently leaking away. And from that, they're expecting then they can sort of roll the clock back to make a much better, put better constraints on how long would it have taken for the current atmosphere to have gotten to this state under the assumption that it was much thicker back then. I mean, realistically, you need an atmosphere that's, so right now we're at about 6 millibars. You need about 300 millibars of pressure to actually have liquid water stable on the surface. And so that's 50 times denser atmosphere than what we have right now. And there's lots of reasons for that, which we can talk about at length, but we know what it is now, and we're trying to figure out how it changed.
But if in that earlier time, at least a billion years, say, that Mars had water on it, that is a time frame in which at least life was able to get started here on Earth. I think it's, we have it at 3.8 billion. I actually did one of those stories somewhere in that neighborhood, but that was the first time in which we could actually see some sort of remains from that. So it's believed actually that life began on Earth within 100, 200 million years.
And it could have formed and then been wiped out by lots of impacts and then formed again. And so those are sort of the gray areas.
How long ago with the Schultz's star do they think it came by?
Oh, I should have mentioned that if I didn't. About 70,000 years ago. So a little tidbit of other information. At that particular time, when it got to within a light year, it's still a very, very faint star, and it's just kind of amazing that at that point, its current brightness, it would have been about a 10th magnitude star, which is about, it's not quite 100 times fainter, about 50 times fainter than you could have seen with your naked eye. So it still would not have been a naked eye star for people here on Earth, though it's an active. Those red dwarfs are actually fairly active in terms of flares, so they may have flared up, and they can get as maybe even 1,000 times brighter. So it's possible that our ancestors saw that star. That flare up. Well, that was the thing, is that it was still at the edge, so that's not enough to really cause a lot of disruption with what's going on in the Oort cloud there. So, but we think that when we do, because we do certainly have passages in, it takes us, we've been going around the center of our galaxy about 16 times or so, about 250 million years each passage. We get close to a lot of other stars and things like that in those passages, and then those ones that get fairly close can cause kind of a more of an onslaught of comets and such.
Question about the background microwave radiation.
Mm-hmm.
Like, if you have an explosion, the light would be like a ball that's going into infinity, and Big Bang happened 13 billion years ago. How can you see that? Because it should be like way out so far that.
Yeah, so the question is, why do we even see this background radiation? And you have to kind of take your mind away from thinking of it as an explosion from one point of space moving out into the other point of space. The Big Bang happened everywhere. All of space is moving away from one another. So when you go back to that particular time there, which is 380,000 years, so I could transport myself, and I'd look around. The universe that it was about 1,000 times smaller in size, which is 1,000,000 times more dense and everything, but which is still not very dense. But it was much hotter that time. The expansion cools the universe. And so if I sat myself in that time, I'd look around and I'd see, basically a hotter radiation there. So as it expands, we see further and further out into our universe, but that where we're seeing that radiation coming from has been cooled because of that expansion of the universe. So we see, when we talk about our own universe, it's our actually observable universe. We look in all directions, and we can only see in this direction and this direction as the age of the universe. So we see the microwave radiation coming from that part of the universe. It has taken the 13.8 billion years essentially to get to us. Same over here in all possible directions. It's a hard thing to wrap your head around, but basically it's a much bigger universe than what we see.
So I always thought of the universe after a Big Bang that you should be able to look at like wavelengths, like through a Doppler effect or something, and figure out which direction is the universe expanding. Where's the outer part of the universe versus more the center of the universe? Does that make sense? Because wavelengths that are moving towards us. So
yeah, well, everything that we see out in the distant universe is actually moving away from us. In every direction. I have a nice little prop that shows little galaxies on the screen that shows that no matter what vantage point, if you have a uniformly expanding universe, no matter where you put yourself in that universe, every person sees the same thing. If I could transfer myself, halfway across the visible universe, go to another galaxy there, I would see the universe expanding away from me there. So everyone sees the same thing. And everything is essentially what we call redshifted. We used to interpret that as a Doppler shift, but it isn't that. It's that the universe is expanding, and by that, the space is expanding. The amount of space between galaxies is expanding. And those photons of light that left 13.8 billion years ago, when they move through space, they lose energy because they get stretched out in this expanding space. So we see the same thing in all. Yeah, it is hard to wrap around. And if I get into that discussion, it's more of a, you have to spend a little time, and I got props and stuff like that. They're nice to show. Yes, we are each the center of our own observable universe. And the universe that we see that looks like we're the center is the fact that if I look out, so I can see galaxies 1 billion light years away this way and 1 billion light years away this way. Those galaxies look different because they are a billion years younger than our own galaxy. So one of the major things of this Planck radiation thing was that right after that Big Bang, after the 380,000 years, the universe was hot as a candle flame, basically, and it was cooling, and then things then started to draw together to actually form, the galaxies and the first stars, actually, and those first stars then got to light up the rest of the universe, and that was the end of the Dark Ages, what we call the reionization of the universe, and that was a big result of the Planck thing, was that happened a little bit later, but only about a half a billion years after the Big Bang and everything. So.
Okay, well,
Can I ask a question?
sure.
So we all three read a book called The Martian. I don't know if
Yes,
you've
by Andrew Weir.
Yeah, it's really
It's a wonderful book, yes.
I'm just wondering, in your opinion, how realistic, or like, where do you look at that and go, okay, this is a little over the top, or?
Well, it's MacGyver on Mars, sort of. It's like, how many disasters can he live through and be ingenious enough to get himself out of? But, I mean, the technology that they were talking about is certainly plausible. He talked about things like the Pathfinder spacecraft and resurrecting some of the electronics. And so, I've got to say, one of the better, if not the best, sort of near future Mars stories that I've encountered. And they are, it's been optioned for a movie. I think it's entering production this year. I don't know who's in it. Ridley Scott is going to be the director, but hopefully they don't totally mess it up. But I'm really looking forward to that. But that would be a book I would highly recommend to anybody to read. It's just very engaging, and it certainly sets the mental picture of what it would be like to actually be on Mars. I think the conditions are spot on. So, okay, well, we'd better stop. On the counter on the way out, beyond these doors, we have handouts about that program next Thursday in the planetarium if you'd like to know more about that. You can exit through the main doors of the museum if you'd like, so you don't have to trudge around through the unplowed sidewalks. Thanks again for coming, and be safe. Hopefully see you next month.